Good morning all. In this video, we will see few examples based on the pumping lemma example or the pumping lemma theorem, which are asked mostly in a examination for 4 to 5 marks. Now, let's see this example. Prove that L is equal to 0 raised to power I raised to power 2, where I is greater than or equal to 1, is not a regular. Now how to give the proof for such a one? First note down the language. Here L is equal to I 0 raised to power I raised to power 2, where I is greater than or equal to 1. Now then elaborate the language in terms of strings. L is equal to, put the values of I is greater than or equal to 1. So first put the value of I is equal to 1. So 0 raised to power I 1 raised to power 2. 1 raised to power 2 means 1. So 0. Then 2 raised to power 2 4. So 4 times we have to write 0. Then 3 raised to power 2 9. Okay, then 9. So the length of string will be here 1 in this case. Then in this case L in first string the length will be the 1. Second string 4 times 0 length will be the 4. Then 9, then 16 and onwards. This language format of the language says that the string has the length that is nothing but the power of square of any integer number. Okay, square of any integer number. So 1, then 4, 9, 16, 25 onwards. If we observe above regular set L, then we found that every string belongs to L is having length which is perfect square of a integer number. Okay. Now how to give the proof? First we will assume here that the given language is regular and the proof by contradiction is we are applying here. Now let us consider n is equal to 4. You can consider any value of n. Just in the solution, in the proof, you just use the value of n as 3, 4, 5. Okay. So you can give the proof for this one. So I have used here n is equal to 4. You can use any value for the n. It is not compulsory. It's just assumption part. Okay. We are assuming that the given language is L. And what we have to prove, it is not a regular. Okay. So proof by contradiction we are applying here. So let us consider that the given language is regular and consider the value of n is equal to 4. You can consider here 3, 5, any value. Okay. Generally I request you to use only 3, either 3, 4 or 5, so that the number of steps will be less. If we consider here the value of n is equal to 10, it will be more complex and to write that one. Okay. So n is equal to 4. Then you can consider here generally n is equal to 3, 4, 5. Okay. Then further we consider we have to consider one string from the state. Now let us consider the string. We know the condition for the string. The length of the string must be greater than the number of states. Okay. So greater than or less than. So if I consider n is equal to 4, then this string is not suitable, but these or onward strings are suitable. So I will use here again the string having a less length. Okay. Then 0, 4 times 0. So let us consider x is equal to 0. Again you can consider any string having length greater than or equal to n. Okay. So that's why I told you to consider the value of n is equal to either 3, 4 or 5. If you consider here 10, then you will need to consider the string x of having length greater than 10. So it will be more complicated, or will take time to write the long string and the long steps, number of states. So n is equal to 4 consider किया है. That's then we can have the string x is equal to 4 zeros. Then we have to divide this string into 3 parts. Okay. U, V, W, such that these are the two conditions we have seen already. So length of the first two part, it must be less than or equal to n, and length of middle part must be greater than 0. So Now we will divide this one. Again, dividation is depends on you. It may vary student by student, but you give the you must satisfy these both conditions. Okay, so here u v w. So let us divide the given string. We have considered the string at is 4 times 0. So u will have only 0, then v will be double 0 and w will be 0. Okay. Now if we pump v for many times, okay, v for many times, then, okay, sorry, here it must be the u v raised to power I w belongs to L, then we say that L is regular, otherwise not regular. Now for I is equal to 1, so we will get the new string x1 is equal to, put the value of u v raised to power I w. I की value 1 है, तो that means we have to write the v for ones, that is 4 times 0. So x1 belongs to L. Then let's see for the another values of I. You have to continue till it will not give the valid string. So for I is equal to 2. Now x2 is equal to, I is equal to 2 means we will get the new string x2 u v raised to power 2, v raised to power 2, I की value कितनी है 2, and then w. So it is equal to u, then write v for 2 times and then w. Okay, so here we have written the x2 is equal to, what is the value of u is 0, v nothing but the double 0, so write that for 2 times, double 0 double 0, and then w value 0. Now this is the new string we obtain by inserting v for 2 times, by pumping v for 2 times. So 1 2 3 4 5 6. So here there are the 6 characters. So length of the string is 6. We know that this language consists of such a strings having length which is a perfect square of any integer number. So this is not a 6 is not a square of any number. So x2 doesn't belongs to L. So means that x2, since x2 doesn't belongs to L, so the L is not a regular language. Okay. So this way we can give the proof of a language. This type of proof is known as a proof by contradiction. Okay. Then let's see another example. Same way we will give the proof for the another example. Okay. Now this is the another example which can be asked, which is asked frequently in the examination. Prove that L is equal to 0 raised to power 1 raised to power n mod n is greater than or equal to 1 is not a regular. Now you will have the questions like this one only. Prove that given language is not a regular. Okay. Not a regular के questions आएंगे examination में. Okay. And only 4-5 problem statements are there which are repeating again and again. Solution. Write down the language. L is equal to 0 raised to power n, 1 raised to power n, where n is greater than or equal to n. Note down the strings. n की वैल्यू अगर 1 पुट करते तो 0 1, 2 पुट करते तो 0 0 1 1, 3 पुट करते तो 0 0 1 1 and so on. Now here you can understand the format of the string. All the zeros appears, later on all ones, then number of zeros equal to number of ones. These are the two conditions. If we observe above language set L, then we found that every string is having equal number of zeros and equal number of ones, and all zeros followed by all ones. So these are the two conditions. Let us consider the n is equal to 0, pumping lemma constant, number of states, n is equal to 6 consider करते हैं. Then further we consider the string x is equal to 0 0 0 1 1. Now we will divide the string into 3 parts, u, v, w, satisfying the two conditions. Length of the first 2 part, it must be less than or equal to n, and the mod of v must be greater than 0. So x is equal to this first 0 u part, v part is 0 0 1, and then w part. Okay. You can have any dividation here. You can consider the any characters in the u, v, w, but must satisfy these two conditions. Then for I is equal to 1. Okay, x1 is equal to new string. Let us consider this x1 is equal to. So I is equal to 1 means as it is string. It is equal to x 0. Then write v for one time w. That is x1 belongs to L. Now consider I is equal to 2. Now we have to write here v for 2 times. Then it will give the string as u will be as it is. V for 2 times 0 0 1. This is one time 0 0 1 second time, and lastly u w part 1 1. So this is u, this is v, this is v, and this is w part. Okay, now here if you see the new string after pumping v for 2 times, 1 and 2 times, now we got here the string as 0 0 0 1 0 0 1 1 1. Now here ones zeros are appearing after 1 following 1, so which is not accepted in the given language, right? Okay, so x2 doesn't belongs to L. So there, since x2 is not belonging to L, so then we can say the L is not a regular language. Okay, let's have a look on the one more example. Prove that L is equal to 0 raised to power n is a prime number is not a regular language. You will have the same type of questions. Prove that language is not a regular language. Okay, now what is here? 0 raised to power n is a prime number. You know the prime number 1, 2, 3, 5, 7, 11, 13, 17 onwards. Okay, so first L is equal to this, then L is equal to this one. Set and elaborate the strings 0, 0, 0, 0, 0 and so on. Then we observe that give the proof by the same way. Let us consider the n is equal to n is equal to 5. Then further string एक consider करते x is equal to जिसकी length 5 से ज़्यादा है, equal to or ज़्यादा. So equal to की string है यहाँ पे 5 की. You can consider 7 also 5 but not 1, 2, 3. Because these are having the length less than the 5. अगर आप यहाँ पे 3 consider करते हो तो you can consider here 3 onwards. अगर आप 4 consider करते हो तो यहाँ से 5 consider करते हो तो you can consider this 3, 4, 5 any constant value. Okay, and any string which has the length greater than or equal to number of states. Then this x is equal to 0, then 0 0 0 5 times. Divide the string into 3 parts u v w. Now we will divide the string. Now we will divide the string into 3 parts u v w, where u is equal to this, v is equal to this, w is equal to this, satisfying the two conditions. Now for I is equal to 1 means same string. I is equal to 2, we get here 0. Then write the v for 2 times. What is the value of v? 0 0 0. So u, this is the u part. Write the v for 2 times. As I is equal to 2, we have considered 0 0 0 0 0 0 0. Now here we get this x2. It has the length 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 is not a prime number, so it is not belonging to L. Let's think for the another one. For I is equal to 3, we get. Now if we pump this I for 3 times, V for 3 times. Okay, U 1, 2, 3 times and W. We know the value of U is 0, single 0. Then V is triple 0 and W is single 0. So write accordingly. You will get the new string x3. Now check whether it is belonging to L or not. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Sorry, 9, 10 and 11. 11 characters are there. So 11 is a prime number. So this x3 belongs to L. Okay. Similarly, you can check for the I is equal to 4 also. Okay, but here x2 and x4 are not belonging to L, even though x3 is belonging. But we have such a thing that all the strings generated by pumping V for many times must belongs to L. Then and only then it is a regular. If any string doesn't belongs to L, then we say that the language is not a regular language. So this way we can give the proof for such a problems which can frequently ask in the examination. एंड दिस टाइप ऑफ प्रूफ इज नोन एज अ प्रूफ बाय कॉन्ट्राडिक्शन। पहले हम कंसिडर करें कि लैंग्वेज रेगुलर है और फिर उसको प्रूव करें कि नॉट रेगुलर है, कॉन्ट्राडिक्शन प्रूव। ओके, थैंक यू ऑल।